221B, Group 6. We are doing our Lesson 18 group quiz. How did you guys find the material this week?
Just tedious, that's it.
Yeah, it wasn't too bad.
It was mostly similar to what we've done before in like the quantitative, and we already learned about the categorical, which was kind of like combining different lessons.
Yeah.
I think for me the hardest part, and the nice thing is they said in the video, you do not have to do this by hand, because trying to do it by hand is going to take hours.
Yes.
And you probably will still get it wrong. So, all right, I'll read the first thing. For the next 9 questions, we will review the PTC tasting study with different data. Out of 70 females in the sample, 52 can taste PTC. Out of 59 males in the sample, 42 can taste PTC through the data presented here. Let P1 be a proportion of females in the population that can taste it, and let P2 be males. The research question for the study is given here. Is the proportion of females who taste PTC different from the proportion of males?
So the first one I got 0.743.
Yeah, let me bring up my Excel real quick. So what did you guys get then? Or are you still looking it up?
I haven't put it in yet. Sorry, I just got my quiz opened. It was taking forever.
It's cool. I'm bringing up Excel right now. Camden's pretty ahead of us.
What did you say it was? It was Camden?
0.743.
All right. Let's just make sure we're all getting the same thing when we'll go on. All right. No offense.
Oh, no, that's cool.
I'm a proud believer that quantity gets quality in math. So that if everyone has the same answer, either they're all right or the question's wrong.
Does it matter which ones we put as 1 and which one we put as 2?
Yes, female is 1.
Female's 1. Okay.
That does matter in here because it's a comparison of 1 versus 2, and that changes if you mix it up. Then it completely changes.
Yeah, obviously, like you want to do like both. You want to. Yeah, no, I know what you're saying. Yeah, okay.
All right. Okay. So yes, FYI, numbers you're putting in are the yeses. So who can taste? So 52 would be your first number. Out of 70 would be the second. That makes sense. So it looks confusing at the table. The table is also showing no. You're simply looking at the yes in this.
Yeah. And what's the type of test? Are we looking for not equal to or?
It's not equal to. So 0.743, Camden.
Yeah, that's what I was getting.
All right, I'm getting 2. What about you, Davis?
Yep, that's what I got.
All right, Spencer, you're here?
Yep.
All right, cool. Then let's move on. I'm for P hat 2 again, 0.712.
Likewise.
All right.
Yep.
Thank you, Excel.
I know, seriously.
That formula is really intimidating. All right, which set of hypotheses is appropriate for addressing the research question? I think it's just the first one.
Yeah.
Yeah. Well, you guys, for just that first one, I mean, for the first couple that we did, all you have to do is just divide the yeses by the total. And that's how I got those.
FYI, let me change 5 is actually the last one. Look at carefully at the, is it P hat we're comparing or P's?
Well, but if you look at it, it's P's for the first one and then P hats for the second one. So that can't be right because we're looking.
Yeah, I'm just checking.
I think it's A.
All right, that's cool.
Paying attention.
I just wanted to make sure. All right. So let's Remind me again what point estimate is.
The point estimate is the z-score.
Yeah. All right. And is the z-score, are you getting 0.394?
0.394, yeah.
All right.
Thank goodness we don't have to do that one by hand. That would be worse.
Margin of error, we do have to do this by hand, so I'll let you guys take a second.
Is it the same? Is it the same equation? Because I never found the margin of error equation in this one. Was I just over?
Well, what you're doing is taking the confidence intervals and taking the I believe the second one minus the first one, and then divide by 2.
Oh.
He told us, he had a Zoom video a couple of lessons back, that you actually the only way you find the margin of error is take the confidence interval on the table and find the average between the two. That is your that's your.
I'm getting 0.154.
Okay. Give me 1 sec to check that.
Hey guys, so I am on the line. This is your TA. My name's Anna. Nice to meet you guys.
Nice to meet you.
So it's just like go through your quiz like you normally do. I'm just like really here to answer any questions you might have, and then also like if I hear you guys kind of going the wrong direction, I'll step in. But
what are you guys getting for the margin of error?
I got 0.154.
Yep, that's what I got.
All right, sounds good to me.
Low bound is 0.123, high bound 0.185.
Make sure the lower bound's negative.
That's right.
Right.
And what's the high bound? That's the 0.185, right?
Mm-hmm.
Should be it. Yeah.
Table is life-saving. All right. So I'm guessing it's failed to reject a null, right?
Yes.
It's way too high.
Yeah, what was the p value? Yeah, definitely.
I think the p value is almost 0.7. So.
Yeah.
All right. 11. Which of the following statements best describe the outcome of the study?
There is insufficient evidence to suggest that the true proportion of females who can taste PPC is less than no. It would be the last one.
Yeah.
There's insufficient evidence to suggest that the true proportion of females who can taste PPC is different from the true proportion of males.
Yep, that sounds good to me. I was just double checking the hypothesis to make sure we're doing it right. All right. For the next 9 questions, we review the mortality rates and day of admission heart attack study with different data. Out of 118,519 who had a heart attack during a weekday, 16,713 had died. Out of 42,447 had a heart attack on the weekend, 6,155 had died. Usually the data represented here. So P1, the patients who were had a heart attack and admitted on a weekday who died. P2 is the patients who had heart attack and on the weekend who died. The question is the proportion of patients who had a heart attack and admitted to the hospital on a weekday to die less than the proportion of those on the weekend who are admitted?
So we want to just go ahead and put this into Excel, and then we can.
Yeah, that sounds good to me.
Figure everything out.
So just remember to put the ones who died because that's fun.
Yeah, and or the group 1 is the weekday, so it's that first number.
Yep.
If someone want to share screen their Excel, because I'm share screen this quiz, that would have both up.
I can do that.
Cool. Thanks, Camden. So make sure your type of test is P1 is less than P2. What you guys get in for, well, first let's go to 12. Are conditions satisfied? I think yes.
All right, let's go. Let's do it out just to make sure.
Okay, sure.
7, 13.
Well, because the conditions are if the n times p is greater than 10 or greater or equal to.
Mm-hmm. It's less than, right? Is what we're doing. P1's less than P2.
Yeah.
Okay, just to make sure. Yeah, I mean, we might as well just go through and do it just to make sure. I mean, pretty sure it's gonna be.
Yeah, that's fine. I'm cool with that.
Pretty sure it's gonna be fine, but.
So the formula, I believe, is n times p hat is greater than or equal to 10, correct?
Yeah, and you're gonna do P1 and P2 separately.
Yeah. Well, I think just looking at our numbers in general, it's gonna be harsher than.
Exactly. Yeah, we're good. I just did it, and obviously good. So yeah.
Yeah. I mean, it's always good to check, but. 13, which have hypothesis. I think it's the last one.
Yep.
Yeah.
All right. P hat 1. I'm getting 0.141. Is that what you're getting?
Yes.
Oh, what the freak?
Am I wrong, Davis?
How am I not getting that? What were your read off your numbers for the?
You want me to share screen?
No, just go ahead and read them off because I have it
Okay.
pulled.
X1, 16,713.
Oh, I put them in backwards. That's yeah. Okay. What was the answer?
0.141.
It's all good.
Yeah, it happens. And P hat 2, I'm getting 0.145. That what you're getting, guys?
No.
Nope.
P2?
I'm getting 0.170.
I got 0.145.
All right, what are your numbers, Camden, for X2 and N2?
6,155. 36,292.
Where did you get the 36,000?
Hang on a second. Let me look
That's
at
wrong. That's the survive number, not the total number.
Yeah.
Oh, you're right. 42,447.
Yeah. That's why it's great to have a group to double check stuff.
I agree.
All right. So we agree then it's 0.145.
145 sounds good.
All right.
Does he score?
I'm getting negative 2.020.
Me too.
I
Everyone else getting this? Okay.
Yeah, sounds good.
Spencer, you doing good?
Yep.
All right. Getting the court to your last question, which should you shade to the left or the right for the?
So we're looking for.
Let me just put it in real quick.
Should be to the left.
Yeah, because we're looking for everything less. We're looking for less than, right?
Yeah.
Yeah, I think we're looking for is P1 less than P2. So this is. Yeah, that makes sense to me. So it would be to the left, correct then?
Mm-hmm.
Believe so.
And then the p-value I'm getting is 0.022.
Me too. That's what I got.
0.022.
So we reject it.
Yes.
So in English, there is sufficient evidence to conclude that force of a heart attack may not happen on a weekday.
I think it's the third one.
Yeah.
Yeah.
All right, I will go ahead and submit and see if what we get.
Should be good.
Guinea pig.
Yeah. The point estimate is wrong. I think there's a different thing for that. Everything else is right. It's just the point estimate.
What number is that?
Let me see. It's 6. Hey, Anna.
Yeah.
Can you explain the point estimate for us?
Yeah, so it's the margin of error equation. Anyway, it doesn't matter. So with the point estimate, so this equation is just the lower bound plus the upper bound, and then you divide that by 2.
The lower bound plus the upper bound.
Okay.
I guess
Yeah, and that gives you the point estimate.
All right.
Maybe not.
We're gonna have to re-enter our data though. Can one of you guys do it for me?
Well, we have the lower bound.
I can actually, yeah.
We have the lower number.
Because it's just 8 and 9 is your lower bound and your upper bound.
No, that's not what I'm talking about. I just submitted it, and so I have to retake it. So I'm gonna need to. If you guys can help me with those real quick.
Yep,
That's
I've got
okay.
mine up on. I'm sharing mine, so.
All right, cool. I'll pull it up then.
Plus the upper bound.
All right, give me 1 sec to get there. All right, 3 is.
0.743.
Yep. All right, 4.
0.712.
Thank you,
David,
guys.
you want to double check me on these?
I've already, every answer that we did was correct except for that one on the point estimate.
Okay, I just want to make sure that I was getting the right ones on
Yeah.
with you guys.
So
First
I
one?
think they're good. So 6 is the one we got wrong. Did you change it?
Yeah, it's 0.031 is what I'm getting. Because it's, so if you do the lower bound plus the upper bound divided by 2.
Okay, cool. Thank you, Anna.
Oh yeah, no problem. You guys did great, so glad I could help a little bit.
Yeah, I always get confused between I know what margin of error is, but the point estimate and test statistic confuse me a little bit. I always get them kind of mixed up.
So what's the difference between that and the margin of error, I guess?
That's probably what I'm going to go do now.
Say, Anna,
Yeah.
what is, Cameron was asking, you can explain the definition of the point estimate, I'm guessing.
Yeah.
Oh, okay. So I 1 second. I think that there's a part in the reading that explains it pretty well. Let me see if I can find it.
All right, thank you.
If you guys want to keep going, and then I'll get back to you.
Yeah.
That's good.
What was 8 again? Sorry.
Number 8. It was negative 0.123.
Well, thank you.
18.022. I'm just talking out loud to myself, sorry. No. And it's the third one, okay. All right, let me just double check this.
What was number 6? Oh man, that's the one we all. Oh, 0.31. Wait.
Yeah, we changed it. All right, 100%. I'll leave mine up real quick, so if you guys need to make sure, I think it got everything right though, except for 6.
Okay, so someone for 6, they just said 0.31, so I just want them to make sure it's 0.031.
0.031, yeah.
Yeah. Okay, cool.
I
1
hope
second, I'm trying to find that.
All right, we good then?
Yeah, wait for the definition here.
Yeah, no, that's fine. I'm just making sure I can close my screen.
It's like,
Yeah, sometimes I feel like I know how to do things, and sometimes I don't really think about what they are. So
Yeah, because the margin of error is the difference between because the point estimate is the middle between the margin of errors, right?
yeah, that's what I think. I'm pretty sure that's what it is. It's yeah, exactly what you said. It's the middle, and then the margin of error is your confidence, how sure you are it's in between those numbers.
Okay,
Yeah.
that makes sense.
so the margin.
Okay. I can't find a thing in the textbook for it. Sorry, what?
So the margin of error is the it's the lower bound minus the upper bound divided by 2, and then the point estimate is you add them and divide it by 2, right?
So close, but the upper bound minus the lower bound. So you'll always be minusing the smaller number by the larger number.
Okay. Yeah.
Mm-hmm.
Okay.
Are we good then?
I'm good with that. Hey, thanks a lot, Anna.
Cool.
So just FYI, I will send the teacher an email after this talking about our design study.
Oh, sorry.
So we were looking at his responses for our design to study, and we weren't sure he could, because he had some interesting comments that didn't really make sense what our thought was. So I'm gonna just email him anyway. That I had to talk to him about my travel plans, and so I'll just let him know that this is what we're thinking. Can you just something like that and see what he says?
Okay. Yeah, and then we can make any changes we need to on Thursday.
Wednesday, right? Or do you need to do Thursday?
Are we doing Wednesday? Yeah, Wednesday. Sorry, that's what I meant.
All right.